Hello class, and thank you for watching this video on the characteristics of a quadratic function in standard form. In this video, you will learn how to find the axis of symmetry, the vertex, and identify the domain and range of a quadratic function in its standard polynomial form. Now, let's begin with some vocabulary. Now, the quadratic equation creates a U-shaped curve called a parabola. And the formula, the standard form of writing this equation, is y equals ax squared plus bx plus c. Now, the polynomial, the parabola, can open in one of two directions. Our parabola can open upwards, like this if our equation y equals to a positive x to the second power. Our axis of symmetry is this vertical line here that cuts the parabola in half. The vertex is the turning point on the parabola, which in this situation is the lowest point. This right here is the vertex. We call this the vertex of the parabola, which in this example is our minimum value. This is the lowest value that the graph is going to reach, which right now is at the origin of 0, 0. Axis of symmetry. Now, let's look at this parabola here. This one here. For this parabola, y equals to negative 1x squared. And the parabola, as a result, opens downwards. This blue line is still referred to our axis of symmetry. But our vertex, which is at the origin of 0, 0, is now the maximum value. This is the highest that the parabola is going to reach. So because of that, the range of our function is going to be all of the values less than that highest point of 0. So the range for this one would be all of the values of y from negative infinity to 0, including 0. While when the parabola opens upwards, the range is going to be the minimum value, which is 0, to the maximum value of infinity. Now, what difference do you notice about the graph in the equation? Well, the graph again opens in opposite direction. When we have a positive x squared, the parabola opens up, and if we have a negative x squared, the parabola opens downwards. The bx and the plus c are going to shift the graph in different directions. They're going to shift it horizontally and shift it up or down depending on what these numbers are. Okay? Now, like I mentioned, the vertical line that divides the parabola into two equal parts, that's called again your axis of symmetry. And the formula to determine where this axis of symmetry is the following formula. It's x equals to negative b divided by 2a. Now the turning point, again, that maximum or minimum value, that's referred to as your vertex, like I mentioned earlier. We also refer as a turning point where the graph changes direction. And if the vertex is the highest point, that is the maximum. So that would be in this situation right here, that's the maximum. And if it's the lowest point, that is your minimum. Like I mentioned again up here, your minimum. So let's see how we determine again our axis of symmetry and of course the vertex and all that. Well, without graphing, looking at number 1, let's determine without graphing if each function is going to have a max, a minimum value, and then see what the symmetry, the axis of symmetry and the vertex is. So for example number 1, The equation is 4x squared. Since the x squared value is positive, again, this is our x squared value, and it's positive, that means that the parabola is going to open upwards. So I'm going to just draw a sketch of this, and it's going to open upwards. Oops. I meant to do this instead. Let me erase this. And our parabola, like I was saying, opens upwards. And the reason for that, again, is because this number right here in front of the x squared is positive. So that means that the vertex, the turning point of this thing, is going to be the lowest. So this function has a minimum value. Now, in order to determine the axis of symmetry, since this technically is 4x squared plus 0x, notice that we don't have an x term and we don't have a constant, those two values are going to be 0. So the value of A here is the number 4, the value of B is the number 0, and the value of C is also going to be 0. And the way that we calculate the axis of symmetry is by using this formula here. Negative B divided by 2 times A. And negative B is this number of 0. So negative 0. And 2 times the value of A. A is 4, which is equal to 0 divided by 8. So our value is 0. So our axis of symmetry is at x equals to 0. Now, our vertex, again, starts and is located on our axis of symmetry. So the value of our vertex has an x coordinate of 0. Now, to figure out what the y coordinate of our vertex is, what we're going to do is that we're going to get our function f of x equals to 4x squared, and replace the x value with that 0. So f of 0 equals to 4 times 0 squared, which is 4 times 0, which is also equal to 0. So our vertex is located at 0, 0. Okay? All right, very well. Let's move on now to the second example. So for this example right here, notice we have negative x squared plus 9x. And because there's no constant, there's again supposed to be 3 terms. Remember, the standard way of writing the polynomial is y equals to ax squared plus bx plus c. So we have the x squared, we have the bx, but we don't have the plus c because the plus c again is 0. So we're going to put that there. Now, since the value of a is negative, since this first term, since the x squared is a negative number, that means that the parabola is going to open downwards. And therefore, the vertex, again, the turning point where it turns is going to be the highest point. So this one has a maximum value and not a minimum. Well, to identify where the vertex is located at, we're going to use the following equation. X equals negative b divided by 2a. So our a value here is this negative 1. Our b value is positive 9. And the value of c again is 0. So we're going to replace the b with 9 and the 2 with negative 1. 9 negative of positive 9 is negative 9. And 2 times negative 1 is negative 2. So when we divide this, that's going to equal to positive 4.5. So our axis of symmetry is positive 4.5. So now our vertex has the exact same x coordinate because, again, the vertex is located in the center, and this is our center line. X equals to 4.5 is our center line, and our vertex is located exactly right there in the center. Now, to figure out what the y value of our vertex is, what we do now is plug in 4.5 into our function. So f of 4.5. So we have negative 4.5 squared plus 9 times 4.5. And let's do this. Where am I? Here we go. Problem number 2. So we're plugging this in to our calculator. So we're going to start by plugging in negative, parentheses, 4.5, raise that to the second power, plus 9, parentheses, 4.5. Let me try that again. Parentheses, I meant to delete, not clear. Plus 9 times 4.5. And that equals a total of 20.25. So our vertex is at 20.25. Okay. Moving on to the next example. Okay. So for our next example, notice again the standard way of writing our quadratic is y equals to ax squared plus bx plus c. Notice that the middle term doesn't have an x. The reason for that is because this is not bx, this is our c. So this equation technically is negative 3x squared plus 0x plus 4. So that means that the value of A is negative 3, the value of B is 0, and the value of C is positive 4. And again, since the value of A is negative, since this number in the very front is negative, that means that the parabola is opening downwards and the turning point is the highest point. So this parabola is going to have a maximum like the previous one. Now to figure out what the axis of symmetry is, we use the formula x equals, and move this over here to the side. We're going to use the formula x equals negative b divided by 2a. So substituting in negative b with 0, substituting in negative 3 for a, we're going to end up with 0. Since 0 divided by negative 6 is still 0. So that is our axis of symmetry. X is equal to 0. Now to figure out the vertex, what we're simply going to do now is replace the x with 0. So we have negative 3 times 0 to the second power plus 4. So negative 3, let me clear this. We have negative 3, parentheses 0 squared plus 4. That equals a total of 4. So that is the y value of the vertex. So our vertex is located at 0 and at 4, 0, 4. Let's see, let's do our last example. So in this example, it's already written, again, all of the terms are now here. So a is equal to 1, b is equal to negative 8, and c equals to positive 9. Since the value of a is a positive number, that means that our parabola is opening upwards, and our turning point, the lowest point, is our vertex. So our vertex is the lowest point. So this one has a minimum value and not a maximum. Now to figure out what the axis of symmetry is, we're going to use our formula of negative b divided by 2a. So the negative of negative 8 divided by 2 times 1. Well, the negative of a negative 8 is positive 8, and since we're going to divide that by 2, that's going to give us 4. So our axis of symmetry is x equals 4. Now to figure out the vertex, we now simply get that 4 and plug it into the equation. So 4 is raised to the second power. 8 gets multiplied with 4 plus 9. And let's use our calculator to simplify that. So 4 squared minus 8 times 4 plus 9, that equals a total of negative 7. So f of 4 is negative 7. And that is our vertex. So 4 for x, negative 7 for y. Okay, now let's look at the back now, and now let's use again the axis of symmetry and the vertex in order to graph our function. So the first thing I want to do, let's start with example 6, okay? Let's start with example 6. First thing I'm going to do is identify where the vertex is. So here, since the value of A is equal to 1, the value of B is the number negative 6, and C is 11, we're going to figure out our vertex by using the formula x equals negative B divided by 2 times A. So continuing, we have that B again is, let me zoom out a little bit, B is negative 6. So we're going to get the negative of that negative 6 and divide that by 2 and the value times the value of A, which is 1. So the negative of negative 6 is positive 6. This is 2. And this is now dividing. 6 divided by 2 is 3. So that's going to be our axis of symmetry. So there is this invisible vertical line here that we're just going to simply use a dotted line for just to, again, there's no reason why it has to be dotted, but we're just going to make it dotted. Again, making the parabola, again, this is the center of the parabola. So we have the parabola that's going to look to the left, and the parabola that's going to be, again, symmetrical to that on the right side. Now, to figure out the y value again, where the center, again, is going to be located at on this line, which is the y value of the vertex, we are now going to plug in this value of 3 into the actual function. So we're doing this. We're doing f of this value of 3 for our function. So we have x squared minus 6 times that value of x plus 11. And again, we're replacing that x with this 3. So let me bring out the calculator here and move it to this side. And we're 3 squared in parentheses minus 6 times, again, that value of 3 plus 11 is a total of 2. So when x is equal to 3, we have our center point right there, our vertex at 2. What we're going to do now is simply identify 2 points to the left and 2 points to the right from that center point. So 2 points to the left of that 3 is the number 4. Let me hide that. We have the number 4. That's this one over here. And the next number after 4 is 5. So we're going to put 4 and 5 below that. And above the number 3, we're going to put the 2 numbers to the left of that. So since our center right here is 3, to the left is 2 and 1. So we'll put 2 and then 1. Okay. So now the only thing left to do is to figure out what the value of y is when x is equal to those values. So let's start off with 4. We'll do the ones on the right side. So let's plug in now the number 4 into this equation. So we have, again, in parentheses, 4 to the second power minus 6 times 4 plus 11. Which gives us a value of 3. So at 4, we have a value of 3. So we have that point there. Okay. So with that point there, again, because the dotted line, this dotted line right here in the middle is this axis of symmetry, to preserve symmetry, that means that there has to be a point, again, to the left of that. That's going to preserve the symmetry. So if this point is at 4, 2, there has to be a point right here, which is at 2, 3. At 4, 3, I'm sorry, there has to be a point right here at 2, 3. So when x is equal to 2, the y value is going to match up to the same thing as on the right side. So that one's also going to be 3. Now to figure out what the y value is with 5, again, we just now plug in 5 into our function. So it's now going to be 5 squared minus 6 times 5 plus 11, which is equal to 6. So at 5, we have a point of 6. And again, in order to preserve symmetry, that means that at 1, the y value is also going to be 6. So our parabola is going to look like this on the left side. And on the right side, it's going to look the exact same way. Okay, well, obviously going through that point. Okay, so there you have it. So it's a curve like that. Now that we have the picture of this thing, let's identify the domain and the range. Let me make this smaller and move it over here. Well, the domain of our function is going to be all real numbers. Because it's a parabola, there is no boundary on the left side. It's going to continue getting wider and wider and wider. So the x values are going to go all the way to negative infinity. And the same thing on the right side. The graph is going to continue getting wider and wider and wider. So the x value is going to go again all the way to positive infinity. So that's the domain. Now the range, however, that is going to be different for every problem. On this particular problem, since the lowest value that the graph reaches is 2, again, that value there 2, that's going to be the lowest y value. Remember the range of the y's. That is the lowest y value that the graph reaches. So our range is going to be all of the values of y from 2 to positive infinity. See, to the numbers below that, the y values are 3 and 6. Notice that the numbers are getting bigger for y. And the numbers on the right of the center, 3, the y values are also getting bigger. So 2, and then the number gets to 3, and then from 3 to 6. So you see those numbers are getting higher and higher and higher. So the y values are going to be from 2 to infinity. Okay, now let's look at a different example. Let's look at example... Let's look at example number 7. Okay, so for example number 7, I want to start the same way. First, I'm going to need to figure out what is my axis of symmetry. So using our formula, x equals negative b divided by 2a. Here the value of a is 2 and the value of b is negative 8. So we're going to get the negative of negative 8 and divide it by 2 times the value of a, which is also 2. Negative of negative 8 is positive 8. 2 times 2 is 4. And dividing 8 by 2 is 2. So this is our axis of symmetry right here at positive 2. Now to figure out the y value, we're now going to plug in 2. So we're going to plug in 2 into our function. So that would be 2 times 2 squared minus 8 times 2 plus 6. Remember, I'm plugging into this function right here. So I'm replacing these x's with this number. And now let's have our calculator help us out here. Let me clear this. We have 2 times 2 squared minus 8 times 2 plus 6, and that equals to negative 2. And let me put that in blue. So that point is right there. 2, negative 2 right there. Okay? Now, let me make this smaller. Okay, so now that I have that, we're now going to identify again the other possible x and y values. Well, again, from here, what I want to do to fill out the rest of this table is I want to focus again from this center point, from this vertex, again, that point right here, this center line, 2 values to the right and 2 values for x on the left. So for the x values above 2, we're going to use 1 and 0. So 1 and 0, and we're obviously going to put them in order. So 0 and then 1. So 0, 1, 2, as you see right there. And then going to the right, the next numbers would be 3 and 4. So we're just simply going to list them in consecutive order. 0, 1, 2, 3, and 4, with 2 being in the middle. So now let's look at the y values for those respective coordinates. So we'll start with 3. So using the same function, we're now going to replace the x's with 2. So just like the, let me hit enter, just like the one that we see right here on top on the calculator, it's going to be 2, but this time the x is going to be 3. So 3 squared minus 8 times 3 plus 6, and that gives us 0. So this value here is 0. So at 3, the value is 0. And again, because it needs to preserve symmetry, that means at 1, that's also going to be 0. Now let's substitute in 0 for the value, 4 for the value of x. So 2 times 4 squared minus 8 times 4 plus 6. And that value is going to be 6. So 4, our y value is 6. And again, in order to preserve symmetry, that means that to the left 2 units, since this point here is 2 units from our center to the right, then 2 units from the center to the left has to be another point. And that point right there is 0, 6. Now our domain, let me graph it. So the left side looks like this, and the right side looks like that from the vertex. Now our domain is going to, yet again, be all real numbers. So from negative to positive infinity. And the range is all of the values from the lowest point, which here is the lowest point is 2. Our lowest point is 2 again, to positive infinity. So that is our range. Okay, let's look at the last examples. Look at example number 5. For example number 5, we'll start by again identifying what the vertex is located at. So x equals negative b divided by 2a. And in this situation, since there is no x term, no constant either, so it's only negative 3x squared plus 0x plus 0. So our value of b is 0, and our value of a is negative 3. Well, 0 divided by anything is still going to be 0, so our center and our axis of symmetry, this time I'll do it in red because it's going to be in the center at 0, which is right here on the y-axis. The y-axis is the equation x equals 0. So that is our axis of symmetry, x equals 0. Now to figure out the vertex, I'm going to use that 0 and plug that 0 into our function. So that's negative 3 times 0 to the second power plus 0x plus 0, which is going to just be 0. So our vertex is at 0, 0. So that's that point right there. So to the left of 0 is the number 1 and the number 2 for x's. So from this x, the next x is 1, and the next x after that is 2. And to the right, negative 1 and negative 2. So negative 1 and negative 2. Now let's figure out what the corresponding y values are. So we'll do the positive side. Let's put the positive side here. So our equation is negative 3. We're going to replace the x right now with 1, with that 1 right there, and raise that to the second power. And we're not going to do the plus 0x and all that stuff because, again, it's 0. So we're just going to put that part in there. And that's negative 3. So 1, negative 3. Now, again, to preserve symmetry, that means that there has to be a point also with a y value of negative 3 to the left side. So negative 1, negative 3. Now let's plug in 2. So negative 3 times 2 to the second power, that's negative 12. So 2, negative 12. And again, to preserve symmetry, that means at negative 2, the y value also has to be 12. So when we graph the left side, it looks like that. When we graph the right side, it's going to look like that. And our domain, again, is all real numbers. And the range this time is, oops, wrong one. This one's the one I want to highlight. This point right here is our maximum value. Okay, remember this is our axis of symmetry. This is where the vertex is located at that coordinate right here of 0, 0. So the y value of the vertex now happens to be the highest point. So that's the maximum value. So our range is going to go from negative infinity down here. Okay, because it's not going to stop at negative 14. It's going to go all the way down to negative infinity. And it's going to stop right here. It doesn't go any higher than that value, which is this y value of 0. So that is our range. And we close it with brackets because, again, we include 0 in that point there. So now let's look at the last example. So for the last example, again, our task is to identify, again, the exact same things. So we need to identify our axis of symmetry. So we begin by using x equals negative b divided by 2a. And here our b value is negative 1a is equal to negative 1/2. That's the number in front of the x squared. So this is a. And since x is the b term and that number in front of that is negative 1, our b value is negative 1. So the negative of negative 1 divided by 2 times our a value, which is negative 1/2. So let's see, the negative of negative 1, well, that's obviously going to be positive 1. But what does 2 times, what does 2 times negative 1/2 equal? So we will type it in like this. To type in 1/2, we use the division symbol. I kind of went a little bit fast there, so let me delete this. So we type in the negative 1. And to put it over 2, we use the division symbol to get the fraction kind of bar that's slanted over 2. And that equals to negative 1. And positive 1 divided by negative 1 is negative 1. So that's the center of our parabola. So our center is going to be located right here. This is our axis of symmetry. Okay, now to figure out the vertex, we're going to plug in that negative 1 into the equation. So f of x, and x again is going to be replaced with negative 1. And our function again is negative 1/2. We'll replace the x with negative 1, square it, and then minus negative 1. So let's type that in. Now, if I want to put a fraction symbol on these yellow calculators, I first have to hit I have a shortcut for all of this, is the alpha, the green button, the alpha key, and then the y equals, and I get shortcuts right here. I could also do it if I go to math. Here, all of my shortcuts are under math. And if I go all the way down, where is it? Here, under number, under math to the right, if I go all the way down to number, I see this notation here. Okay. That lets me write as a fraction. But the shortcut is to hit the alpha button, which is the green button, and then the y equals, and I get again my fraction. I want to get a fraction. Okay, so my fraction is negative 1 over 2, or I could put the negative sign in the front. Let me delete that and put the negative sign in the front. And in parentheses, we have negative 1, close the parentheses, raise it to the second power, minus negative 1. And that's 0.5. Okay, so that is our vertex. So at negative 1, we're going to have a y value of 0.5, which is right here, since the distance, as you see here, from here to here, that's 1. From 1 to 2 is right here, 2 blocks, so that means these are going by 0.5s. So this is going to be the vertex right there. That's the highest or lowest point that the parabola is going to reach. So now let's find other points. Since our center is at 1, to the right again, consecutive numbers to the right of 1 are 0 and 1. So you're going to put those below the 1, 0 and 1. And above the 1, the numbers before 1 are negative 2 and negative 3 consecutively. So again, look, negative 3, negative 2, negative 1, 0, 1 in order. So we have those in consecutive order from top to bottom, from least to greatest, going from the top to the bottom. Okay, now to figure out what the y values are, we just now substitute in these x's into this equation up here. Let me just highlight it all in yellow, to this equation up here. So let's start by plugging in 0. So we have negative, let me do the fraction. So alpha y equals, to put in a fraction, and let me put the negative sign on the front. So 1 divided by 2 times the value of x, which is going to be 0 to the second power, minus, again, 0. And that's going to equal to 0. And in order to preserve symmetry, that means that this value also has to be 0. Now let's plug in 1. So negative fraction 1/2. We now multiply the 1/2 with this new x value of 1. And we're going to subtract, again, that x value of 1. And that's negative 1.5. And again, in order to preserve symmetry, that value also has to be negative 1.5. So at 0, we're at 0, and at 1, we're at, hold on, did I do something wrong? Yeah, I forgot to square this. I forgot to square this when I was doing again the center, so I need to do the center again. Okay, so let's do negative alpha y equals 1/2. Our center is at negative 1, so negative 1 squared minus negative 1. And no, that's equal to 1.5. At 0, that's at 0. And now we're going to do positive 1. So let me delete this. Okay, and I got it right. Okay. Oh, I see where my mistake is. I plot this point in the wrong place. So this point, negative 1, 0.5, shouldn't be down here. That's my fault. I apologize. I'm sorry, that shouldn't be down there. That point should be up here. This is where positive 0.5 is. Positive 0.5. So negative 1, 0.5 should be there. That makes more sense now. So 0, 0, and at 1, we should go down to 1, negative 1.5. So that would be there. And another, again, to preserve symmetry, we have to have those points there, which again matches up exactly to what we have above. At negative 2, our y value is 0. And at negative 3, our y value is also negative 1.5. So let's connect those points from the vertex to the left and the vertex to the right. The parabola looks like this. So our domain again is all real numbers, and the range is going to be from negative infinity this time, because this point now is the highest point. This again, the vertex, this point right here is now the highest, since everything again you could see to the left, above, and below that, these numbers again get smaller than 0.5. Our range will be all of the values of y from negative infinity to 0.5. And there are your examples on how to graph a polynomial function using again the standard form, the polynomial form, quadratic function using this polynomial form. Now, if you have any questions, please send me a message through email, or you could also send it through Parent Square. I appreciate you watching, and like always, I hope you have a great day. Goodbye.